Hello, good morning. Okay, due to power cut, there is a little inconvenience. Can see? I'm audible. Audible. So power hoitu, so for little bit technical problems is there. So a little delay of the class. Are you here, students? Are you here? I am audible to you. Can see? Hello, just chat me. Shivaprasad, Abhishek, Sumeda. I am audible to you now? Sumeda, Shivaprasad, Sanjana. Yes, okay. Okay. I think you are saying yes, sir. ಓಕೆ ನನ್ನ ಲಾಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಅದು ಆರ್ ಕ್ಯೂಬ್ ರೂಟ್ ತಗೊಳ್ಳೋದು ಇನ್ನು ಎರಡು ಪ್ರಾಬ್ಲಮ್ಸ್ ಅಷ್ಟು ಉಳಿತವ್ರಿ. ನಾನು ಅದನ್ನು ಸಾಲ್ವ್ ಮಾಡ್ತೀನಿ. ಹೊಸ ಟಾಪಿಕ್ ಮಾಡಬಾರ್ದು ಅಂತ ಹೇಳಿ ಅದನ್ನು ಜಗಾಗತ್ತೀನಿ. ಇನ್ನೂ ಒಂದಿನ ಎರಡು ದಿನ ಆಫ್ಲೈನ್ ಕ್ಲಾಸಲ್ಲಿ ತೊಗೊಂಡು ಮಾಡ್ಬೇಕಂತ ಹೇಳಿ. ಇಸ್ ಇಟ್ ಓಕೆ? ನಂಗೆ ಅದು ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಸ್ವಲ್ಪ ಅಲ್ಲೇ ವಾಪಸ್ ಗಿಚ್ಚಾಡೋದು ಅಥವಾ ವಾಪಸ್ ಅದನ್ನು ಇದನ್ನು ಮಾಡೋದು ಐ ಆಮ್ ನಾಟ್ ಕಂಫರ್ಟ್ ವಿತ್ ದ್ಯಾಟ್. ಐ ವಿಲ್ ಸಾಲ್ವ್ ದ್ಯಾಟ್ 3 ಕ್ವಶನ್ಸ್ ಟುಮಾರೋ. ಓಕೆ, ನೋ ಪ್ರಾಬ್ಲಮ್. ಮಾಡೋ ನೆಕ್ಸ್ಟ್ ಮಾಡೋಣ. ಈಗ ಅದನ್ನ ವಾಪಸ್ ತೊಗೊಳ್ಳೋದು ಮತ್ತು ನಿನ್ನ ರಿಫ್ರೆಶ್ ಆಗಿ ಈಗಾಗಲೇ ಮಾಡಿದ್ನಲ್ಲ 16ನೇದ್ದು ಆ ಥರ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ಮಾಡ್ತೇನೆ. ಓಕೆ, ಇಸ್ ಇಟ್ ಓಕೆ ಫಾರ್ ಯು? ಅರ್ಥ ಆಯ್ತು ರೀ? ನೆಕ್ಸ್ಟ್ ನಾನು ಒಂದು 3 ಕ್ವಶನ್ಸ್ ಬಿಡ್ತೇನೆ, ಅವನ್ನ ನಾನು ಮಾಡ್ತೇನೆ ನಾಳೆಗೆ. ಬಟ್ ಐ ವಾಂಟ್ ಟು ಈಗ ನಂಗೆ ಹೊಸ ಟಾಪಿಕ್ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಲಿಕ್ಕೂ ಇಷ್ಟ ಇಲ್ಲ. ಹೊಸ ಟಾಪಿಕ್ ಮಾಡಿದ್ದೆ ಅಂದ್ರೆ ಮತ್ತೆ ಆನ್ಲೈನಾಗೆ ನಂಗೆ ಹೆಂಗೋ ಮೂವ್ ಆಗ್ತೇನೆ ಸ್ಲೋ ಆಗಿ. Should I complete? Should I start once again a new lesson today? Here in the online? ನಂಗೆ ಬೇಡ ಅಂತ ಹೇಳಿಬಿಟ್ಟೇನಿ. ಅದೊಂದು ಐ ವಿಲ್ ಸಾಲ್ವ್ ದ್ಯಾಟ್ 3 ಪ್ರಾಬ್ಲಮ್ಸ್ ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಬಿಕಾಸ್ ಐ ಡೋಂಟ್ ವಾಂಟ್ ಟು ಅಗೇನ್ ನಾಟ್ ಡೂಯಿಂಗ್ ಅಗೇನ್ ಆ್ಯಂಡ್ ಅಗೇನ್ ನಾಟ್. ಇಟ್ಸ್ ನಾಟ್ ಇಂಟ್ರೆಸ್ಟಿಂಗ್. No, yes sir, don't. Okay. I will take one more concept. Shall I explain some things regarding labs now? ಲ್ಯಾಬ್ ಬಗ್ಗೆ ಹೇಳೋಣ್ರಿ ಒಂದು ಸ್ವಲ್ಪ. ಯಾಕಂದ್ರೆ ನಿಮ್ಗೆ ಬಂದ ತಕ್ಷಣ ಲ್ಯಾಬಿಂದ ಏನಂತ ಇನ್ಫಾರ್ಮೇಶನ್ ಇರಂಗಿಲ್ಲ. ಜಸ್ಟ್ ಹೆಂಗಿರುತ್ತಂತ ಲ್ಯಾಬ್ ಬಗ್ಗೆ ಹೇಳ್ತೇನೆ. ಓಕೆ, ಬೇರೆ ಇನ್ನೊಬ್ರು ತಗೋಬೋದು ಲ್ಯಾಬ್, ಐ ಡೋಂಟ್ ನೋ. ಲೆಟ್ ಮಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಅಬೌಟ್ ಸಮ್ ಥಿಂಗ್ಸ್ ರಿಗಾರ್ಡಿಂಗ್ ಲ್ಯಾಬ್. ಓಕೆ, ಸೊ ಶಾಲ್ ಐ ಟೇಕ್ ಲ್ಯಾಬ್ ಥಿಂಗ್ಸ್ ನಾವು? ಸಮ್ ಲೀಸ್ಟ್ ಕೌಂಟ್ಸ್ ಯು ನೋ. ಓಕೆ, ಕಾನ್ಸಂಟ್ರೇಟ್. ಆ ಕ್ವಶನ್ಸ್ ನಾನು ಸಾಲ್ವ್ ಮಾಡ್ತೀನಿ. ಮತ್ತೆ ಈಗ ವಾಪಸ್ ತೊಗೋಬೇಕು ಮೈಂಡ್, ವಾಪಸ್ ಅದನ್ನ ರಬ್ ಮಾಡೋದು. ಡೋಂಟ್ ವಾಂಟ್ ದ್ಯಾಟ್. ಐ ವಿಲ್ ಸಾಲ್ವ್ ದಟ್ ಕ್ಲಿಯರ್ಲಿ, ನೋ ಪ್ರಾಬ್ಲಮ್. ಹಾಂ, ಗೊತ್ತಾಗ್ತದೆ ಹೆಂಗೆ ಮಾಡ್ಬೇಕಂತೇಳಿ. ಕ್ಯೂಬ್ ರೂಟ್ ತೊಗೊಂಡು ಈ ಕಡೆ ಶಿಫ್ಟ್ ಮಾಡಿ. ಬಟ್ ಅವನ್ನ ನಾನು ಇನ್ನೊಮ್ಮೆ ಮಾಡ್ತೇನೆ. ಹಿಂಗೆ ಹೊಸ ಲೆಸನ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಬಾರ್ದು ಅನ್ನೋದಕ್ಕೆ ಐ ಆಮ್ ವೇಟಿಂಗ್ ಫಾರ್ ಟು ಹ್ಯಾಂಡಲ್ ಅ ಫಿಸಿಕಲ್ ಕ್ಲಾಸ್. ಓಕೆ, ಇದನ್ನು ಐ ಡೋಂಟ್ ವಾಂಟ್ ಟು ಟೇಕ್ ದಿಸ್. ಬ್ಯಾಡ್ ಇದೆ, ಬಿಟ್ಬಿಡೋನು. ನೆಕ್ಸ್ಟ್ ನಾನು ವಿತ್ ನ್ಯೂ ಕಾನ್ಸೆಪ್ಟ್ ಐ ವಿಲ್ ಟೇಕ್ ಮೋರ್. Okay, with this, in your first year practicals, laboratories, they are having every year you have to do 12 experiments. Practicals, ಎಷ್ಟು practicals ಮಾಡೋಕ್ಕಾಗಿರ್ತದೆ ಅಂದ್ರೆ 12. ಹೌದ್ರಿ? These carries will 30 marks. Not 12 experiments. One experiment will carries 30 marks for your exam, practical exams. ಸೊ ಒನ್ ಪ್ರಾಕ್ಟಿಕಲ್ ಫಾರ್ ಯುವರ್ ಪ್ರಾಕ್ಟಿಕಲ್ ಎಕ್ಸಾಮಿಗೆ ಬರ್ತೈತೆ ರೀ. ಫೈನಲ್ ಎಕ್ಸಾಮ್ಗೆ, ಪ್ರಾಕ್ಟಿಕಲ್ ಎಕ್ಸಾಮ್ಗೆ 30 marks will be there. So you got it, my dear students? ಫಾಲೋ ಅಪ್ ಆತೀರಿ? ಸಂಜನಾ, ಶಿವಪ್ರಸಾದ್, ಸ್ವಾತಿ, ಕ್ಯಾನ್ ಸಿ ನಾವು ಫಾಲೋ ಅಪ್ ಆತೀರಿ? ಎಷ್ಟು ಮಾರ್ಕ್ಸ್ ಇರ್ತಾರೆ ಪ್ರಾಕ್ಟಿಕಲ್ ಎಕ್ಸಾಮ್? 30 ಮಾರ್ಕ್ಸಿಂದ. ಔಟ್ ಆಫ್ 30 again I am going to divide that 30 into 20 for lab ಲ್ಯಾಬ್ ಮಾಡೋದಕ್ಕೆ 20. Here 6 marks for journals plus 4 for Viva. ನಿಮ್ಗೆ ಇನ್ನೊಮ್ಮೆ ಲೈವ್ ಕ್ಲಾಸ್ನೊಳಗೆ ಬಂದಾಗ ಹೇಳ್ಕೊಡ್ತಾರೆ ಅವ್ರು ಸರ್. ಜಸ್ಟ್ ನಿಮ್ಗೆ ಒಂದು ಇಂಟ್ರೊಡಕ್ಷನ್ ಕೊಡಕ್ಕಂತ ಹೇಳತ್ತೇನೆ. ಐ ವಿಲ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಕ್ಲಿಯರ್ಲಿ ಅಬೌಟ್ ಸ್ಕೇಲ್ಸ್, ಆರ್ಡಿನರಿ ಸ್ಕೇಲ್ಸ್. ದಿಸ್ ಈಸ್ ಯುವರ್ ಪ್ರಾಕ್ಟಿಕಲ್ ಎಕ್ಸಾಮ್. So, in generally, in our day-to-day life, we need to have to measure the things. If you go through the ಟೇಲರ್ ಕಡೆ ಬಟ್ಟೆ ಹೊಲಕ್ಕೆ ಹಾಕಿ ಹೋಗಿರಿ ಅಂತಂದ್ರೆ ಸುಮ್ಮ ಹೆಂಗಾರ ಹೊಲ್ದು ಬಿಡ್ತಾನ್ರಿ. ಇಫ್ ಯು ಗೋಸ್ ಟು ಟೇಲರ್ ಕಡೆ ಹೋಗಿರಿ ಅಂದ್ರೆ, ಟೇಲರ್ನ ಹತ್ರ ಹೋಗಿರಿ ಅಂದ್ರೆ ವಾಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಡೂ? ಏನು ಮಾಡ್ತಾನ್ರಿ ಟೇಲರ್? ಏನು ಮಾಡ್ತಾನ? ಬಟ್ಟೆ ಹೊಲಕ್ಕೆ ಹೋದಾಗ ಅರ್ಬಿ ತೊಗೊಂಡು ಹೊಲ್ದು ಕೊಡ್ತೇನೆ ಅಂತ ತೊಗೊಂಡ್ಬಿಡ್ತಾನ. ದಟ್ಸ್ ಇನಫ್. ದೆನ್ ವಾಟ್ ಈಸ್ ನೀಡೆಡ್? ಏನು ಬೇಕ್ರಿ? ವಾಟ್ ಹಿ ಹ್ಯಾಸ್ ಟು ಡೂ? ಏನು ಮಾಡ್ಬೇಕವ? ನೋ ಸರ್, ದೇ ವಿಲ್ ಟೇಕ್ ದ ಮೆಜರ್ಮೆಂಟ್ಸ್. ಎಸ್, ಗುಡ್. ಐ ವಾಂಟ್ ದಿಸ್ ಆನ್ಸರ್. ಎಸ್, ದಟ್ ಮೆಜರ್ಮೆಂಟ್. ಎಸ್, measurement. So he is going to measure the things. That is called measurement. ಅಳತಿ ಅಂತ ಕರಿತೇವೆ ಕನ್ನಡದೊಳಗೆ. Then ಅಳತಿಗೆ ಇನ್ ಜನರಲಿ ನಾವು ಸ್ಕೇಲ್ ಇಲ್ಲಿ ಅಳಿತಿರ್ತೇವೆ, ರೈಟ್? ದೇ ವಿಲ್ ಟೇಕ್ ಎ ಮೆಜರ್ಮೆಂಟ್. ಎಸ್, ಏನ್ರಿ? ಮೆಜರ್ಮೆಂಟ್ ಅನ್ನ ಅಳಿತಿರ್ತೇವೆ, ಅಳತೆ ಅಂತ ಕರಿತಿರ್ತೇವೆ, ಹೌದಾ? ವಿತ್ ದಟ್ ಮೆಜರ್ಮೆಂಟ್ ಫಾರ್ ಅಸ್ we need a scale. ಸುಮ್ಮ ಅಳತಿ ದಾರ ತೊಗೊಂಡು ಅಳಿತಾನ್ರಿ? ಹೆಂಗೆ ಅಳಿತಾನ್ರಿ? he need a scale for that. What? Measurement done by scale. So scale. How to measure the diameter of an object? ಒಂದು ಲೆಂತ್ ಅನ್ನ ನೀವು ಸ್ಕೇಲ್ ಇಲ್ಲಿ ಅಳಿತೀರಿ. ಯು ಕ್ಯಾನ್ ಮೆಜರ್ ಎ ಲೆಂತ್ ವಿತ್ ದ ಸ್ಕೇಲ್. ಒಂದು ಲೆಂತ್ ಇರ್ತೈತ್ರಿ, ಅದು ನೀವು ಸ್ಕೇಲ್ ಇಲ್ಲಿ ಅಥವಾ ಥ್ರೆಡ್ ಇಲ್ಲಿ ಹೇಳ್ತೀರಿ, ಆರ್ ಥ್ರೆಡ್. ಆಮೇಲೆ ನೀವು ಅದನ್ನು ಹೌ ಟು ಮೆಜರ್ ದ ಡಯಾಮೀಟರ್, ರೇಡಿಯಸ್ ಆಫ್ ಸ್ಫೆರಿಕಲ್ ಬಾಡೀಸ್ accurately. Hangre with a scale. Yeah, which instrument we are using to measure these things? Which instruments we are using to measure that? ಅದನ್ನು ಮೆಜರ್ ಮಾಡಲಿಕ್ಕೆ ಯಾವ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ಸ್ ಯೂಸ್ ಮಾಡ್ತೇವ್ರಿ? ಯು ನೋ ಮೈ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ಸ್ಕೇಲ್. ಕರೆಕ್ಟ್ ರೀ. ಇದನ್ನ ಡಯಾಮೀಟರ್ ಯೂಸ್ ಮಾಡೋಕೆ ಒಂದು ಸ್ಪೆರಿಕಲ್ ಆಬ್ಜೆಕ್ಟ್ಸ್ ಇದ್ದಾಗ ಅಕ್ಯುರೇಟ್ ಆಗಿ ಸಿಗುತ್ತಾ ನಮ್ಗೆ? ಫಾರ್ ಅಸ್ ಇಟ್ ಈಸ್ ಪಾಸಿಬಲ್. ಟೇಪ್ಸ್ ಫಾರ್ ಕ್ಲಾತ್ಸ್. ಎಸ್, ಗುಡ್. ಟೇಪ್ಸ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಕ್ಲಾತ್ಗೆ. ಕರೆಕ್ಟ್ ರೀ. ಕ್ಲಾತಿಗೆ ಏನೈತ್ರಿ, ಲೆಂತನ್ನು ನಾವು ಟೇಪ್ ಯೂಸ್ ಮಾಡ್ತೇವೆ. ಕರೆಕ್ಟ್. ಬಟ್ ಡಯಾಮೀಟರ್ we need to have a special apparatus or special scales called as, let me take a special scale. Your scale is a measuring scale. nim scale use ಮಾಡೋದು ಎದಕ್ಕಂತ ಹೇಳಿ? measuring scale, right? measuring scale. Or let me take one more very important scale, that is vernier calipers. ಏನಂತೇವ್ರಿ? ವರ್ನಿಯರ್ ಕ್ಯಾಲಿಪರ್ಸ್. ನೆಕ್ಸ್ಟ್ ಇನ್ನೂ ಸ್ಮಾಲರ್ ಐತಪ್ಪ ಅಂತಂದ್ರೆ, ಒಂದು ಗೋಲ್ ಐತೆ ಅಂತಂದ್ರೆ, ಆರ್ ಎಲ್ಸ್ ಯು ಕ್ಯಾನ್ ಮೆಜರ್ ದಟ್ ವಿತ್ ಅ ಮೈಕ್ರೋಮೀಟರ್ ಸ್ಕ್ರೂ ಗೇಜ್. ಹೈಟು ಅಥವಾ ಡೆಪ್ತ್ ಅನ್ನ ಎದ್ರಲ್ಲಿ ಎಳಿತೇವೆ ಗೊತ್ತಾ? we are measuring height and depth. ಒಂದು ರೋಡ್ ಒಳಗಡೆ ಒಂದು ಲೈಟಿಂಗ್ ಕಂಬ ನೋಡ್ಬೇಕಂದ್ರೆ ಡೆಪ್ತ್ ಹೈಟು? ಒಂದು ರೋಡ್ ಒಳಗಡೆ ಒಂದು ಲೈಟಿಂಗ್ ಕಂಬ ಇರುತ್ತೆ, ಅಥವಾ ಒಂದು ಪೋಲ್ ಇರುತ್ತೆ, ಅಥವಾ ಒಂದೇನೋ ಲೆಂತ್ ಇರೋದು ಇರುತ್ತದೆ. ವಿ ಆರ್ ಸೀಯಿಂಗ್ ಎ ಲೆಂತ್, ಡೆಪ್ತ್ ಆರ್ ಹೈಟ್? ಡೆಪ್ತ್ ನೋಡ್ತೇವೋ ಏನು ಹೈಟ್ ನೋಡ್ತೇವೋ? ಹೈಟ್ ಎಸ್. ಒಂದು ಊರೊಳಗೆ ಬಾವಿ ಇರ್ತೈತಿ, ಬಾವಿ ಒಳಗೆ ಎಷ್ಟು ಹೈಟ್ ಐತಿ, ಎಷ್ಟು ಉದ್ದ ಐತಿ, ಎಷ್ಟು ಹೈಟ್ ಐತಿ ನೋಡ್ರಿ ಬಾವಿ ಅಂತೇವಿ. ಎಷ್ಟು ಹೈಟ್ ಐತಿ ಬಾವಿ ಅಂತೇವಿ? ಡೆಪ್ತ್. ಎಸ್, ವಿ ಆರ್ ಕಾಲಿಂಗ್ ಟು ಮೇಜರ್. ಇದೊಂದು ಅರ್ತ್ ಸರ್ಫೇಸ್ ಅನ್ಕೋರಿ. ಟು ಸಿ ದಿಸ್, ಇದು ಅರ್ತ್ ಸರ್ಫೇಸ್, ಇದು ಅರ್ತ್. ಟು ಸಿ ದಿಸ್ ವಿ ಆರ್ ಕಾಲಿಂಗ್ ಆಸ್ ಡೆಪ್ತ್. ಇದನ್ನ ಡೆಪ್ತ್ ಅನ್ನೋನು. ಈ ಸರ್ಫೇಸ್ ಇಂದ ಈ ಕಡೆ ಹೋದ್ರಿ ಅಂದ್ರೆ ಅದನ್ನ ಹೈಟ್ ಅಂತ ಕರೆಯೋನು. ವಿ ಕ್ಯಾನ್ ಕಾಲ್, ಇದಕ್ಕೇನಂತೀರಿ? ಹೈಟ್ ಅಂತ ಕರೆಯೋನು. ಸೊ ಇದನ್ನ ಹೈಟ್ ಅಂದ್ರೆ ಏನು ತಪ್ಪಿಲ್ರಿ, ಇದನ್ನ ಡೆಪ್ತ್ ಅಂದ್ರೆ ಏನು ತಪ್ಪಿಲ್ಲ. ವಿ ಆರ್ ಮೆಜರಿಂಗ್ ಇನ್ ದ ಸೇಮ್ ಥಿಂಗ್ಸ್, ದಟ್ ಈಸ್ ಡಿಫರೆಂಟ್. ವಿ ಆರ್ ಮೆಜರಿಂಗ್ ಸಚ್ ಟೈಪ್ ಆಫ್ ಥಿಂಗ್ಸ್ ವಿತ್ ಒನ್ ಮೋರ್ ಸ್ಪೆಷಲ್ ಸ್ಕೇಲ್ ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಸ್ಪೆರೋಮೀಟರ್. ವಿ ಆರ್ ಕಾಲಿಂಗ್ ಸ್ಪೆರೋಮೀಟರ್ ಅನ್ನೋ ಡಿವೈಸ್ಲೆ ಅಳಿತೇವ್ರಿ. Right, we are measuring such things will be measured by measuring scales. So let me take our ordinary scale. First one, measuring scale. I'll take, you got the, which are the different types of scales? You types of scales re ivelokku I can call, these are the types of scales. I can call these are types of SCALES, types of scales. Types of scales. Okay. E types of scales na you can take these scales. These are the types of the scales. Let me introduce which are the types of scales, students. Let me chart. Which are those? Helri yavavu? Vernier calipers. Vernier calipers, micrometer, screw gauge, then sperometer. Let me take measuring scale. Namdu ordinary measuring scale totana. Let me take measuring scales. Okay. Measuring scale. Shall I take? So this is your ordinary scale. Okay. So least count of this is, what is mean by least count? You know what is mean by LC anta karitare, that is called as least count. Least count. What is mean by least count? Idna ನಾವು LC anta kariteve. You know what is mean by least count? Called as a smallest division that can be measured by a measuring scale, called as a smallest division or measurement. A smallest division or measurement, smallest division or measurement, measuring with a measuring scale is known as least count. So this is the definition. Then in your ordinary scale or a measuring scale, which is a smallest division, let me take, this is your scale. ಈ ಸ್ಕೇಲ್ ಒಳಗಡೆ ಇದನ್ನ ನಾ ಹೆಂಗೆ ಡಿವೈಡ್ ಮಾಡ್ತೇನೆ ನೋಡ್ರಿ. In 1 centimeter how many millimeters are there? In 1 centimeter how many millimeters are there? 1 centimeter ಒಳಗಡೆ ಎಷ್ಟು millimeters ಅದಾವ್ರಿ? Yes, 10 millimeters. Good. 10 millimeters. So which is the small least count of your measuring scale is, least count of your measuring scale is LC of LC of measuring scale. That is, let me explain. 1 division, 2 division, 3 division, 4 division, fifth is little bigger. 1, 2, actually ಇದನ್ನು ಹಿಡಿದುಕೊಂಡು ಮಾಡ್ತಿರ್ತಾರೆ, ಒಂದನ್ನು ಹಿಡ್ಕೊಂಡು ಮಾಡಿದ್ರಂದ್ರೆ, so this is the bigger one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 1 centimeter. Next, this is 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, 2. Like this dishes. So, what is the least count of this scale? ಇಲ್ಲಿ ಐತಲ್ರಿ ಈ ಸ್ಕೇಲ್ ಇನ್ least count ಎಷ್ಟು ಹೇಳ್ರಿ ಯಾರಾದರೂ? How much minimum? Least count of measuring scale. Let me answer ಗೊತ್ತೈತ್ರಿ? ಹೇಳ್ರಿ. How much minimum I can measure from this? 0.1 ಏನ್ರಿ ಮಿಲಿಮೀಟರಾ ಸೆಂಟಿಮೀಟರಾ? ಸೆಂಟಿಮೀಟರ್ನಾಗ ಹೇಳ್ರಿ. ಲೆಟ್ ಮೀ ನೋ ಫ್ರಮ್ ಮೆಸೇಜ್ ಡಿಲೀಟ್ ಮಾಡಿಬಿಡ್ತೀರಿ. 0.1 ಏನ್ರಿ? ನೋ ರಾಂಗ್ ವಹಿದಾ ಸಂಜನಾ, ಇಟ್ ಇಸ್ 0.1 ಸೆಂಟಿಮೀಟರ್. ಹೆಂಗೆ ಹೇಳ್ತೇನೆ ನೋಡ್ರಿ. 1 ಸೆಂಟಿಮೀಟರ್, ದಿಸ್ ಈಸ್ 1 ಸೆಂಟಿಮೀಟರ್. 1 centimeter can be divided by 10 millimeters. So that is equals to 0.1 centimeter. So 10 millimeter na divide ಮಾಡ್ತೇವೆ. 1 I can call value of this division is 0.1 centimeter. 0.1 centimeter is equals to 1 millimeter. Right? 0.8 centimeter. How many millimeters? 0.8 millimeter. 8 centimeter ಅಂದ್ರೆ ಎಷ್ಟು ಮಿಲಿಮೀಟರ್ ರೀ? ಮಿಲಿಮೀಟರ್ನಾಗ ಹೇಳ್ರಿ. ಮಿಲಿಮೀಟರ್ಸ್ನೊಳಗೆ ಹೇಳ್ರಿ 0.8 ಸೆಂಟಿಮೀಟರ್ನ. 8 mm, ವೆರಿ ಗುಡ್. 8. 0.9 ಸೆಂಟಿಮೀಟರ್ ಹೇಳ್ರಿ. 0.9 centimeter, that is 9 millimeter. Very good. What is 1 centimeter ಹೇಳ್ರಿ? Yes, good. 10 millimeters. 10 millimeters is equal to ಮತ್ತೆ 0.10 ಅನ್ಬಾರ್ದ್ರಿ, 1 centimeter. So in this way, so what is the value of this mark? ಇಲ್ಲೊಂದು ಮಾರ್ಕ್ ಐತೆ ನೋಡ್ರಿ. ಈ ಮಾರ್ಕ್ ವ್ಯಾಲ್ಯೂ ಹೇಳ್ರಿ ನನಗೆ. ಇಲ್ಲೊಂದು ಮಾರ್ಕ್, ವಾಟ್ ಈಸ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ದಿಸ್ ಮಾರ್ಕ್? ಈ ಮಾರ್ಕಿನ ವ್ಯಾಲ್ಯೂ ಹೇಳ್ರಿ. ಇಲ್ಲಿಗೆ 1 ಆಯ್ತ್ರ. ನೆಕ್ಸ್ಟ್ nobody is answering. Yes, very good. 1.5 centimeter or 15 millimeters? 1.5 centimeters or 15 millimeters. Then least count of your measuring scale ಹೇಳ್ಬಿಡ್ರಿ ಈಗ ಆನ್ಸರ್. least count of your measuring scale. ಅತಿ ಮಿನಿಮಮ್ ಎಷ್ಟು ಮೆಜರ್ ಮಾಡ್ಬೋದು ಈ ಸ್ಕೇಲ್ನಿಂದ? I can measure how much? ಎಷ್ಟು ಮೆಜರ್ ಮಾಡ್ಬೋದು? How much I can measure from this scale? Yes, very good. 0.1 centimeter. Least count of your measuring scale. LC is equal to 1 divided by 10. That is equal to 0.1 centimeter. ಅಂದ್ರೂ ಕರೆಕ್ಟ್, ಅಥವಾ 1 millimeter ಅಂದ್ರೂ ಕರೆಕ್ಟು. This is your is it clear? Then least count of your measuring scale ಅಂತಂದ್ರೆ ಹೇಳ್ತೀರಿ? Will you? Okay, like this we are having least count for this vernier scale. ಇದಕ್ಕೆ ವರ್ನಿಯರ್ಗೆ ಒಂದು ಲೀಸ್ಟ್ ಕೌಂಟ್ ಐತಿ, ಮೈಕ್ರೋಮೀಟರ್ ಸ್ಕ್ರೂ ಗೇಜ್ ಒಂದು ಲೀಸ್ಟ್ ಕೌಂಟ್ ಐತಿ, ಸ್ಪೆರೋಮೀಟ್ರಿಗೆ ಒಂದು ಲೀಸ್ಟ್ ಕೌಂಟ್ ಐತಿ. ಎಕ್ಸಾಮಿಗೆ ಲೀಸ್ಟ್ ಫೈಂಡ್ ದ ಒಂದೇನೋ ಕೊಡ್ತಾರ್ರಿ, ಸ್ಪಿಯರೋ ಅಥವಾ ಪೈಪೋ ಅಥವಾ ಇನ್ನೇನೋ ಕೊಡ್ತಾರ. ಸೊ ಹಿಂಗೆ ಸ್ಕೇಲ್ can find it that in the your regular practicals. ಇವನ್ನೆಲ್ಲ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀರಿ ನೀವು. ಓಕೆ, ಇವನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀರಿ. ಎನಿಥಿಂಗ್ ಎಲ್ಸ್ ಟು ಆಸ್ಕ್? ಲ್ಯಾಬಿಂದು ಸ್ವಲ್ಪ ಮಾರ್ಕ್ಸ್ ಗೊತ್ತಾದ್ರೆ ಲ್ಯಾಬ್ ಮಾಡಿಸಿದ ಮೇಲೆ ಮಾರ್ಕ್ಸ್ ಡಿವೈಡ್ ಹಾಕವ್ರಿ. ಪ್ರಾಕ್ಟಿಕಲ್ಗೆ ಅಗೇನ್ ದೇ ಆರ್ ಗೋಯಿಂಗ್ ಟು ರೈಟ್ ಏಮ್ ಕೊಟ್ಟಿರ್ತಾರ. ಯು ಹ್ಯಾವ್ ಟು ರೈಟ್ ದ ಫಾರ್ಮುಲಾ ಟು ಫೈಂಡ್ ದ್ಯಾಟ್. ಓಕೆ, suppose onದಿಷ್ಟು I will give you with this. Find the formula for force, find the formula for speed, find the formula for ಇದು ಬೇರೆ ಇದೆ ಮತ್ತು ನೀವು ಅದನ್ನ ತಿಳ್ಕೊಬೇಡ್ರಿ, ಅದು ಮುಗೀತ್ರಿ ಸ್ಕೇಲಿಂದ. ಯಾಕಂದ್ರೆ ನಿಮಗೆ ನೆಕ್ಸ್ಟ್ ಸ್ಕೇಲ್ ಹೇಳಕ್ಕಂತಂದ್ರೆ ನಾ ಸ್ಕೇಲ್ ಡ್ರಾ ಮಾಡ್ಬೇಕು, ಭಾಳ ಮೈನ್ಯೂಟ್ ಇರ್ತೈತ್ರಿ ಅದು. ಈಗ ಒಂದಿಷ್ಟು ಫಾರ್ಮುಲಾಸ್ ನೋಡೋಣ. ಲೆಟ್ ಮಿ ಟೇಕ್ ಸಮ್ ಫಾರ್ಮುಲಾಸ್. ಓಕೆ, ಸ್ಪೀಡಿನ ಫಾರ್ಮುಲಾ ಹೇಳ್ರಿ, ವೆಲಾಸಿಟಿ ಫಾರ್ಮುಲಾ ಹೇಳ್ರಿ. ಸ್ಪೀಡ್, ವೆಲಾಸಿಟಿ, ಎಕ್ಸಿಲರೇಷನ್, ಫೋರ್ಸ್. Write down all these things. ಬರ್ಕೋರ್. ಸೊ ನೆಕ್ಸ್ಟ್ ಮೊಮೆಂಟಮ್, so write the formula for these things. Okay, so next chemistry class will be runs. Okay, we'll discuss that 3 questions in the next class. Okay, we'll start the new lesson in the when you come to the live. Okay, tomorrow I'll give some basics, square roots, cube roots, ಅವನ್ನೆಲ್ಲ ಹೇಳ್ಕೊತೀನಿ. ಅವ್ನು ಹೇಳಿದ ಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಬೇಸಿಕ್ಸ್ ಅಂತ ತೊಗೊಳ್ಳೋಣ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು, ಹ್ಯಾವ್ ಎ ನೈಸ್ ಡೇ.
Good morning, everyone. So, in the yesterday classes we have started new unit that is states of matter. Unit yaudu? Unit 5, states of matter. So in the yesterday's class we have discussed what is matter. What is matter? Matter andre ಏನು? What is matter? Matter means anything that occupies space, has a mass, whose presence can be felt is called as matter. For example, if you take pen, air, book, everything in this universe is nothing but it is matter. ಈಗ ಮ್ಯಾಟರ್ ಅಂದ್ಕೂಡ್ಲೆ ವಾಟ್ ಇಸ್ ಮ್ಯಾಟರ್ ಮೇಡ್ ಅಪ್ ಆಫ್? ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ಅರೈಸ್ ಆಗೋದು ಮ್ಯಾಟರ್. ಮ್ಯಾಟರ್, ವಾಟ್ ಈಸ್ ಮ್ಯಾಟರ್ ಮೇಡ್ ಅಪ್ ಆಫ್? ಮ್ಯಾಟರ್ is composed ಅಂತಂದ್ರೆ made. What it is made up of? It is made up of atoms. Matter na ನೀವು further divide ಮಾಡಿದ್ರೆ finally further subdivisions, if you go further subdivision, divide it, finally divide ಮಾಡಿದ್ರೆ the last part what you get is atom. So that means atom is nothing but it is the what? The fundamental unit. It is a fundamental unit, building block of any matter. So this you have already studied in structure of atom. According to which theory? Dalton's theory. John Dalton's theory. He tells that matter is made up of atoms. Atoms are small particles. It cannot be further divided. So atom ಅಂತಂದ್ರೆ ಏನಂತ ನಿಮಗೆ ಗೊತ್ತು. The word atom is derived from a Greek word atomio, which means uncuttable ಅಥವಾ indivisible. So this theory or this this philosophy, this theory was given by whom? John Dalton. That is why this theory is called as Dalton's theory. Dalton's atomic theory you have studied in structure of atom as well as in some basic concept adrallu barutte. Okay, later on, after doing so many experiments, we found that atom also contains subunits, subparticles. What are the subparticles present in atom? Atom is not divisible anta ಹೇಳ್ತಾರೆ, indivisible anta ಹೇಳ್ತಾರೆ, but atom contains, inside atom also there are subatomic particles. What are those subatomic particles? You have studied already, you know. Subatomic particles ಯಾವ್ದು? There are many subatomic particles, but basically we will study only 3. What are those? Proton, neutron and electron. Proton, neutron, electron and neutron. So idanna bittu innu ಬೇರೆ subatomic particles adavu. So many subatomic particles are there, but we still now we discovered only these 3 subatomic particles, right? So iga states of matter alli, matter is nothing but anything that occupies space. Matter is composed of atom in turn, atom. For example, this atom combined with another atom to form molecule. This is a molecule. These are atoms, this is molecule. Atom combine agi enagutte, molecule form agutte. Okay, so like this, the interaction between many atoms, for example this atom, in the interaction between many atoms, the force of attraction or repulsion between all these atoms is called as, the force of attraction or repulsion between the atoms or between the molecules is called as, intermolecular forces. Intermolecular forces. It is a force of attraction or repulsion. It is a force of attraction or repulsion that hold together molecules or atoms, that hold together molecules or atom, right? So that is why you can see solid, in solid what happens, subatomic particle is in solids ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ intermolecular force is greater, means attraction is greater in solids ಅಲ್ಲಿ intermolecular force strong ಇರುತ್ತೆ, intermolecular forces are strong, that is why they are attracted to each other. That is why solid has a definite structure, definite shape, definite volume, because atoms are arranged in an order, closely packed. Intermolecular forces in solid is stronger, whereas in liquid it is less. Intermolecular forces in liquid is less, so that is why atoms are almost freely moving. I mean, it is just like flowing. Liquid will flow, right? So why liquid will flow? Liquid yak flow agate antandre atoms, arrangement of atoms is loosely packed, loosely packed, whereas in solid it is closely packed. So intermolecular force in solid is strong, in liquid it is less. Intermolecular forces, intermolecular force liquid alli enagirutte less, it is less. That is why atoms are freely moving like this, loosely packed, right? Whereas in gases, if you take gases alli enagutte, it is free, random, molecules are randomly moving, random, it is random, free, they are free, atoms are free. So that means intermolecular force here is less, completely, it is still less, very less, very less. So that is why gases can occupy the entire space. Gases, for example, if you open helium gas bottle ಇಲ್ಲಿ open ಮಾಡಿ ಒಂದು ಬಾಟಲ್ ಅಲ್ಲಿ helium gas fill ಮಾಡಿ ಅದನ್ನ ಹಿಂಗೆ just open ಮಾಡ್ರಿ, so it will be occupying the entire room, ಇಡೀ ರೂಮನ್ನ ಆಕ್ಯುಪೈ ಮಾಡುತ್ತೆ. ಅದೇ ಎಲ್ಲ ಗ್ಯಾಸನ್ನ ಕಲೆಕ್ಟ್ ಮಾಡಿ ನೀವು ಒಂದು ಸ್ಮಾಲ್ ಬಾಟಲ್ ಅಲ್ಲೂ ಹಾಕ್ಬೋದು. Following, you can take the helium gas and keep in preserving in a small bottle also. The same helium gas can occupy the entire space. That means what? It shows that it can be easily dispersed antandre it can be easily moving, dispersed. This is another property of gases. Another gases, this shows that gases can be easily compressed means ಇಷ್ಟು ಆಕ್ಯುಪೈ ಮಾಡೋ ಗ್ಯಾಸನ್ನ ನೀವು ಕಾಂಪ್ರೆಸ್ ಮಾಡಬಹುದು. You can compress it, it can occupy so much space also. So that means it is compressed, it can be easily compressed. Gases are very easily compressed. Okay, other solid na, for example, this is a solid, right? This is a solid. So this ಈಗ ಇದು ಇಷ್ಟು ಸ್ಪೇಸ್ ಆಕ್ಯುಪೈ ಮಾಡ್ತಾ ಇದೆ, ಇದನ್ನ ನಾವು ಇನ್ನೂ ಕಾಂಪ್ರೆಸ್ ಮಾಡಬಹುದು. Can we compress this, making it to occupy only so much space? No, means solids cannot be compressed, whereas gases can be compressed. That is one of the property of gases. Later on we'll see that. So right, then we were discussing about intermolecular forces. Intermolecular forces are nothing but these are the forces of attraction or repulsion between atoms or molecules, all the attractive forces are called as van der Waals forces. All the attractive intermolecular forces are called as van der Waals forces, which is a weak force of attraction. Then we have seen the different type of intermolecular forces, that is dipole, dipole force, then dipole, induced dipole, induced dipole force, third one dispersion force, dispersion force or London force. Okay, here in this dipole force it is between two polar molecule, polar plus polar, both are polar here, polar and polar. Okay, here polar and this is non-polar, one is polar, one is non-polar. Here in this case both are non-polar, 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 like this. Okay, so here polar ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ positive end, negative end, positive end, negative end. This one and this one negative ಇದು. Positive and negative, this will attract here like this. Okay, whereas here positive, negative, and here both are negative, negative or positive, positive, like this. ಈ ತರ ಇರುತ್ತೆ. And this one, so let us take both are positive here. So this one will attract this molecule. A kind induce ಆಗುತ್ತೆ. ಮೊದಲ ಇದು ನಾನ್ ಪೋಲಾರ್ ಇರುತ್ತೆ, but later on the effect of this polar make it induced polar, induced polar, induced dipolar ಆಗುತ್ತೆ. One end ಅಲ್ಲಿ positive ಬರುತ್ತೆ, full positive, one end ಅಲ್ಲಿ negative ಹೋಗುತ್ತೆ, like this, because of nucleus and electrons, like this. London forces only ಅಷ್ಟೇ. This is a weak force and it is temporary force for a time being, temporary force, both will be acting polar polar, right? So this is what we have studied in the last class with example. And now next one we'll discuss is, as I told you, states of matter. How many states of matter are there? What are the states, different states of matter? States of matter: solid state, liquid state, gaseous state, right? So there are three states of matter. One more state is there: solid state, liquid state, gaseous state. Plasma is also there, but still now we have no exam or information or anything about plasma state. Still research is going on this. So solid state, liquid state, gaseous state, we'll stick only till these three states. Anyhow, solid state you are going to discuss, as I told you, we are going to study in class 12. Liquid state and gaseous state we are going to study here in class 11. This we are going to study in class 12, right? So we'll start with gaseous state first. Gaseous state, right? Gaseous state, gas, gaseous state. Total how many elements are there in a periodic table? How many elements in periodic table? Total how many elements are there? Periodic table 118 elements. See, 118 elements ಈಗ at present periodic table ಅಲ್ಲಿ ಅದು. Modern periodic table contain 118 elements. Out of these 118 elements, 118 elements ಅಲ್ಲಿ, can you name any element? Which element is in liquid state, which element is in gaseous state, which elements are in solid state? First coming to gaseous, liquid ಅಲ್ಲಿ ನೋಡೋಣ. Which element is in liquid state at room temperature? At room temperature ಅಂತಂದ್ರೆ ನಾರ್ಮಲ್ ಕಂಡೀಷನ್ಸ್ ಅಲ್ಲಿ ಯಾವ ಎಲಿಮೆಂಟು ಲಿಕ್ವಿಡ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಇರುತ್ತೆ ಅಟ್ ರೂಮ್ ಟೆಂಪರೇಚರ್? ನಾರ್ಮಲ್ ಕಂಡೀಷನ್ಸ್. ವಿಚ್ ಎಲಿಮೆಂಟ್ ಅಕರ್ ಆಸ್ ಲಿಕ್ವಿಡ್? ವಿಚ್ ಎಲಿಮೆಂಟ್ ಅಕರ್ ಆಸ್ ಗ್ಯಾಸಸ್? ವಿಚ್ ಎಲಿಮೆಂಟ್ ಅಕರ್ ಆಸ್ ಸಾಲಿಡ್? ಸಾಲಿಡ್ ಬಗ್ಗೆ ನಾವು ಆಮೇಲೆ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಫಸ್ಟ್ ಲಿಕ್ವಿಡ್ ಹೇಳ್ರಿ. ಯಾವ ಎಲಿಮೆಂಟು ಲಿಕ್ವಿಡ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಐತಿ? ವಿಚ್ ಎಲಿಮೆಂಟ್ ಇಸ್ ಇನ್ ಲಿಕ್ವಿಡ್? Anyone? If you see periodic table, if you can open periodic table, it is given there. Blue color in the blue ಅಥವಾ ಯಾವುದಾರು ಕಲರ್ ಕೆಳಗಡೆ ಮೆನ್ಷನ್ ಮಾಡ್ತಾರೆ ಅಲ್ಲಿ, ಲೈಕ್ ದಿಸ್. ಸೊ ಇಫ್ ಇಟ್ ಇಸ್ periodic table ಲೈಕ್ ದಿಸ್, ಲಿಕ್ವಿಡ್ಸಿಗೆ ಅಂತಾನೆ ಬೇರೆ ಕಲರು ಬೇರೆ ಕಲರಿಂದ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾರೆ periodic table ಅಲ್ಲಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, if this is a periodic table ತರ ಆಗಿದೆ, ಅದೇ ಅಂತ ಎಕ್ಸಾಕ್ಟ್ ಏನಿಲ್ಲ, somewhat resemble, right? S block, D block, P block, and here you have F block. So in modern periodic table, if at all there is any they will mention this will be having different color. For example, this has blue color. Here somewhere you have blue color. Here somewhere you have blue color. ಈ ತರ. So blue color ಇರೋದು they will mention here. Blue color liquid, orange color solid, green color gases. ಆ ತರ ಮೆನ್ಷನ್ ಮಾಡಿರ್ತಾರೆ periodic table ಅಲ್ಲಿ. ಆ ತರ ಡಿಫ್ರೆಂಟ್ ಕಲರ್ ಇಂದ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾರೆ. Now tell me which is in, if you see periodic table you will find out. Okay, ಈಗ ಹೇಳ್ರಿ ಯಾವುದು which element is in liquid? Only two elements are there, that is bromine and mercury. Hg ಅಂತಂದ್ರೆ mercury is in liquid state, bromine is in liquid state, mercury, only these two are in liquid state. How many elements are in gaseous state? So these two are in liquid state. Gaseous state ಅಲ್ಲಿ ಎಷ್ಟು ಅದಾವು? How many are there in gaseous state? Can you tell anyone? All the noble gases ಯಾವ್ದು ಎಲ್ಲ noble gases all are in gaseous state. Okay, all the noble gases. ಯಾವ್ದು noble gas? Helium, neon, argon, krypton, xenon, radon. All noble gases are in gaseous state. For example, noble gases. So noble gas ಎಲ್ಲಿ ಬರುತ್ತೆ? ಇಲ್ಲಿ. It comes here. This is the place of noble gas. Group 18. ಇದೆಲ್ಲ helium, neon, argon, krypton, xenon, radon. Helium, neon, argon, krypton, xenon, radon. Okay, so this is the noble gas group 18. Okay, so I'll tell you how many gases, how many elements exist in gaseous state. So total naturally occurring elements in gaseous state are 11. What are those? Helium, neon, argon, krypton, xenon, radon. All these are noble gases which comes under group 18. Apart from this, you have other elements also which occur in gaseous state. Other elements ಯಾವ್ದು? Hydrogen occur in gaseous state, oxygen, nitrogen, and two halogens, fluorine, chlorine. So total ಎಷ್ಟಾಯ್ತು ನೋಡ್ರಿ? 1 2 3 4 5 6 7 8 9 10 11. Total 11 elements are in gaseous state. Okay, understood? All noble gases, hydrogen, oxygen, nitrogen, two halogens. These are halogens. Let me see in which group they are present. Group 1, I'll write your group number. Group 1. Group 1 ಅಲ್ಲಿ hydrogen ಬರುತ್ತೆ. Okay, group 15, group 16, group 17, group 18. Group 18 ಅಲ್ಲಂತೂ all this. So here you have a gap. Okay, group 18 you have helium, neon, argon, krypton, xenon, radon. All this. In group 15 you have nitrogen, group 16 oxygen, fluorine, fluorine, chlorine. So these are the elements present in periodic table which exist as liquids. Now tell me how many elements occur in solid state. Solid state. See, liquid alli 2, gaseous alli 11. Remaining how many? Solid state. Solid state alli ಎಷ್ಟು? ಇಲ್ಲಿ ಯಾಕೆ ಗ್ಯಾಪ್ ಅಂತಂದ್ರೆ here you don't have any liquids. I mean ಇದು ಗ್ರೂಪ್ 1 ಅಲ್ಲಿ ಒಂದು ಗ್ಯಾಸ್ ಇದೆ, ಗ್ರೂಪ್ 2, ಗ್ರೂಪ್ 3, ಗ್ರೂಪ್ 4, ಗ್ರೂಪ್ 5 ಇದರಲ್ಲಿ ಯಾವುದು ಗ್ಯಾಸಸ್ ಇಲ್ಲ. ದೇರ್ ಆರ್ ನೋ ಗ್ಯಾಸಸ್ ಬಿಕಾಸ್ ಗ್ರೂಪ್ 1 ಇಸ್ ಆಲ್ಕಲಿ ಮೆಟಲ್ಸ್. ಗ್ರೂಪ್ 1 ಅಲ್ಲಿ ಬರುವಂತ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸು ಆಲ್ಕಲಿ ಮೆಟಲ್ಸ್. ದೇ ಆರ್ ಆಲ್ ಸಾಲಿಡ್ಸ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಸೋಡಿಯಂ, ಪೊಟ್ಯಾಷಿಯಂ, all these are in the solid state. Rubidium, cesium ಇದೆಲ್ಲ ಸಾಲಿಡ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ಗ್ರೂಪ್ 2 ಅಲ್ಲಿ ಇರುವಂತ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ಗೆ ಅಲ್ಕಲೈನ್ ಅರ್ತ್ ಮೆಟಲ್ಸ್ ಅಂತೀವಿ. ಅಲ್ಕಲೈನ್ ಅರ್ತ್ ಮೆಟಲ್, ಅರ್ತ್ ಕ್ರಸ್ಟ್ ಅಲ್ಲಿ ಸಿಗುವಂತ ಮೆಟಲ್ಸ್ ಅಲ್ಕಲೈನ್ ಅರ್ತ್ ಮೆಟಲ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಕ್ಯಾಲ್ಸಿಯಂ, ಮೆಗ್ನೀಷಿಯಂ, ಆಮೇಲೆ ಇದು ಬೇರೆ all these elements whatever we get in the earth crust, calcium, magnesium, strontium ಇವೆಲ್ಲ ಗ್ರೂಪ್ 2 ಅಲ್ಲಿ ಬರುತ್ತೆ. ಹಾಗೆ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸು ಈ 2 ರಿಂದ 13 ವರೆಗೆ ಬರುವಂತ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸು ಸಾಲಿಡ್ ಇರುತ್ತೆ, ಇಲ್ಲ ಲಿಕ್ವಿಡ್ ಇರುತ್ತೆ. So group 13, group 14, all these elements are solid or they may be liquid. So directly group 15, group 16, group 17, group 18 ಇದಿಷ್ಟೇ gaseous state. ಅದರಲ್ಲಿ ಇದಿಷ್ಟೇ. ಓಕೆ, ಅದಕ್ಕೆ ಇಲ್ಲಿ ಗ್ಯಾಪ್ ಇರೋದು. So remaining elements, ಎಷ್ಟು elements? 105, right? Is it 118 elements minus 11, 12, 13 ಎಷ್ಟು? 105. So 105 elements are in solid state. Okay, some elements, 118 elements ಅಲ್ಲಿ some elements are artificially made, man made elements. So last ಗೆ ನಿಮಗೆ ಇಲ್ಲಿ F block elements ಏನಿದಾವಲ್ಲ, here all these are man made elements. Okay, here whatever you elements you have, uranium, after uranium ಎಲ್ಲ radioactive element in ಬರುತ್ತಲ್ಲ, so this is artificially made, artificially synthesized nuclear fission reaction in the, so that is a man made elements, artificially made elements. So now recently 119 element is also present. 119 element also is exist. ಈಗ 119th element ಪತ್ತೆ ಆಗೈತಿ. It is found out. Yeah, F block elements, certain elements are man-made. Certain elements, for example, uranium is naturally occurring uranium. Uranium naturally occurring, but remaining after uranium ಏನು ಬರುತ್ತಲ್ಲ, all that are man-made. Some elements, some elements are naturally occurring. F block allu starting some elements are naturally occurring, but some elements are man-made. Still now we don't have the name for 119th element. 119th element ಯಾವುದು ಅಂತ ನೇಮ್ ಅದರ ಪರ್ಟಿಕ್ಯುಲರ್ ನೇಮ್ ಇಲ್ಲ, ಬಟ್ ಜನರಲ್ ನೇಮ್ is given 119th element. 119th element is given a name by nonium. So this you are going to study in classification of elements. Classification elements alli how to name all the elements. It is given there. Nonium. 9 ittantandre nonium. 8 ittantandre octium. So like that. 1 ittantandre an 2 ittandre bi ಈ ತರ ನೇಮ್ ಈ ತರ ಪ್ರಿಫಿಕ್ಸ್ ಕೊಡಬೇಕಾಗುತ್ತೆ. ಅದಕ್ಕೆ ಅದನ್ನ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಡಿ ಇನ್ ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಆಫ್ ಎಲಿಮೆಂಟ್. Okay, which you are going to study in next class, next unit. Okay, don't worry about that. Now we are talking about gaseous state. Total how many elements are in gaseous state? Total 11 elements are there in gaseous state. Now let us see what is the characteristic properties of this gaseous state. Property, physical property or characteristic, characteristics. Characteristic properties of gaseous state. Can you tell any properties of gaseous state? Anyone? Just know already we have told one example already na helide enadu. Gases are highly compressed. They can be easily compressed. Highly compressible. Yes, highly compressible. So best example, if you seen balloon ಅಲ್ಲಿ air fill ಮಾಡ್ರಿ. So if you fill the balloon with air, it will expand. It can be easily expand and it can be easily compressed. Right? It can be easily compressed, it can be easily expand. If you blow the balloon na blow ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? It will expand. If you compress it, again it can be easily compressed. For example, the same amount 10 liter, you can tell 10 liter of any XYZ gas can be filled in this container. We can fill this container, compress it and fill it. Same 10 ml of gases can be spread in this whole classroom. So that means it can be easily compressed. It can be easily dispersed. Dispersed is also another important phenomena of gases. Okay. Second thing is gases exert pressure. Gases exert pressure equally in all direction. Means gases exert pressure equally in all direction. What does this mean? This means, see, if you take a cube here, this is a cube or container. If you fill the gas inside this, ಈ gas ಯಾವುದೋ ಒಂದು gas XYZ gas na ಇದರಲ್ಲಿ fill ಮಾಡ್ರಿ. This is a container. These are the walls of the container. Walls. These are nothing but walls of container. Okay. So if you fill the gas here, what gas molecules will do? It will exert pressure from all the direction. Equal pressure na exert ಮಾಡುತ್ತೆ. It will push. It will exert pressure on the walls of the container equally. So that is the meaning of this sentence. Gases exert pressure equally in all direction. Second point. Third point. Understood second point? Third point, gases has much lower density than solid and liquid. Low density. It has less density. Density is less. Density means what? What is density? Density, lower density than solid and liquid. Means density, definition ಏನು density ಇದು? Density is given by mass upon volume. Mass upon volume. That means the mass of a gas occupied by certain volume, it is less denser. It can be, you can feel it is less denser. Heavy ಇರೋದಿಲ್ಲ ಇದು, denser ಆಗಿರುತ್ತೆ. Okay. So they don't have any volume, no definite volume and shape. Already you know this sentence. They don't have a definite volume and definite shape. They can assume the shape of the container. They can take the shape of a container. They can occupy the volume of a container. For example, if you take a beaker, this is a beaker. If you take beaker, fill gas here, X gas, it will take the shape of this beaker. If you take a round bottom flask, fill X gas here, it will take the shape of this flask. So it will take the shape of the certain container. Volume also, it can occupy so much of volume here, it can occupy so much complete volume here also. Volume and shape of the gases are not fixed. They assume shape and volume of the container. They mix, gases mix evenly and completely in all proportion without mechanical aid. This is another point, that is gases mix and they mix and spread and spread. For example, as I told you, perfume nodiri, your fog perfume or any other perfume, if you spray that perfume, so what happens, that perfume, whatever gas is there in that perfume, if you spray that, it will completely occupy the classroom. Means it can be easily mixed. There is no need of chemical aid. Chemical aid ಅಂತಂದ್ರೆ ನಾವು ಏನಾರು ಗ್ಲಾಸ್ ರಾಡ್ ಅಥವಾ ಯಾವ್ದಾರು ಒಂದು ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ತಗೊಂಡು ಮಿಕ್ಸ್ ಮಾಡಬೇಕು ಅಂತ ಏನಿಲ್ಲ, ತಾನೇ ಆಟೋಮೆಟಿಕಲಿ ಇಟ್ ವಿಲ್ ಬಿ ಮಿಕ್ಸ್ಡ್. ಸೊ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಈಸಿಲಿ ಮಿಕ್ಸ್ಡ್ ಬಿಕಾಸ್ ವಿದೌಟ್ ಎನಿ ಮೆಕ್ಯಾನಿಕಲ್ ಏಡ್ ಅಂತಂದ್ರೆ ನಾವು ಕೈಯಾರೆ ಹೀಗೆ ಮಿಕ್ಸ್ ಮಾಡಬೇಕು ಅಂತ ಏನಿಲ್ಲ. ಓಕೆ, ಅದರಷ್ಟಕ್ಕೆ ಅದೇ ಸ್ಪ್ರೆಡ್ ಆಗುತ್ತೆ. ಸೊ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಈಸಿಲಿ ಸ್ಪ್ರೆಡ್, it can be easily mixed. For example, your perfume if you spray, it will disperse full in the classroom. Okay, so these are some of the characteristic properties of gases. Understood? Highly compressible, exert pressure equally in all direction, low density than solid and liquid, no definite volume and shape, easily mix and easily can be spread, diffused. So next we are going to discuss is gas loss. Idu next very important concept. From here the real important concept starts. Gas law. Exam point of view, it is very important. Even ನಿಮ್ಮ general knowledge ಗೆ, this is all for your knowledge purpose. But now whatever we are going to discuss here, this is exam point of view, it is very important. Gas laws. What are the different gas law? So gas laws. There are different gas laws. Here we are going to discuss Boyle's law. Second one, Charles law. Charles 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 law. Then next Gay-Lussac law. Gay-Lussac's law. Then you have Avogadro law, Avogadro's law, then ideal gas law. Avogadro's law. Finally, last one you are going to discuss is fifth one, ideal gas law अथवा equation. Okay, so these are the important laws: gas law, Boyle's law, Charles law, Gay-Lussac's law, Avogadro law, ideal gas law. All these are name of a scientist. Okay, so one by one we'll discuss each one in detail. First one, that is Boyle's law. What does this law state? Boyle's law andre enu? Have you studied in the lower classes? At Boyle's law, according to this law, this is based on the experiment of a scientist called as Robert Boyle. He has carried out experiment. In his experiment, according to his experiment, he formulated a law, and that law is called as Boyle's law. This law is a relationship between, this gives a relationship between pressure and volume. Pressure and volume relationship. This is the relationship between pressure and volume. That is called as PV. Pressure volume, PV. Okay. According to this law, at constant temperature anna constant ittaga, pressure of a fixed amount of gas inversely proportional to volume. So with example, we will study that at constant temperature. For example, let us take temperature is fixed 25 degrees Celsius anta itkori. ಈಗ ರೂಮ್ ಟೆಂಪರೇಚರ್ ಈಗ ಪ್ರೆಸೆಂಟ್ ರೂಮ್ ಟೆಂಪರೇಚರ್ ಎಷ್ಟು 25 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಅಂತ ಅಸ್ಯೂಮ್ ಮಾಡೋಣ. ಅಟ್ ದಿಸ್ ಟೆಂಪರೇಚರ್, ಅಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಟೆಂಪರೇಚರು ಇಷ್ಟೇ ಇರಬೇಕು. ಅಟ್ ದಿಸ್ ಟೆಂಪರೇಚರ್ ದ pressure of a fixed amount of a gas. Fixed amount of a gas ಅಂತಂದ್ರೆ, for example, let us take n moles of a gas. Number of moles of gas is n. For example, let us take the amount of gas is n mole. Ishtu 1 mole, 2 mole, 3 mole, like that. So let us take n is 1 here. n ಅಂತಂದ್ರೆ 1 ಅಂತ ತಗೊಳ್ಳೋಣ. n is 1 mole. 1 mole of gas ತಗೊಂಡಿವಿ ಅಂತಂದ್ರೆ, pressure of that 1 mole of gas will be inversely proportional symbol ಈ ತರ ಬರೀತೀವಿ, inversely proportional to volume. Okay, this is the statement given by Robert Boyle. According to his experiment, which experiment he has done, on the basis of his experiment, Robert Boyle says that at constant temperature, pressure of a fixed amount, n mole of a gas is inversely proportional to volume. This is called as Boyle's law. Statement is very important. Statement. This is the statement. In exam, they will ask you state. State ಅಂತ ಅಂದಾಗ complete ಬರೆಯಬೇಕು ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೆ. Complete. This is statement. Mathematical equation. What is, how we can write it mathematically? Mathematical equation will be, I'll write here mathematically, it can be written as P is equal to, pressure is equal to 1 upon V. Inversely ಅಂತಂದ್ರೆ 1 upon V. Inside bracket you have to write at constant temperature and N. N ಅಂತಂದ್ರೆ number of moles. Number of mole is also constant. P is directly proportional to, pressure is inversely proportional to volume. So the inverse P illide volume illide antandre inversely proportional. Pressure is inversely proportional. So if you write like this, it will be directly proportional. Ee tara baradre direct proportional. If you write like this, inversely proportional. Here in this case it is inversely proportional. Okay, like this. At constant temperature and this one, amount of gas. If you remove this proportionality constant ತೆಗೆದ್ವಿ ಅಂತಂದ್ರೆ proportionality, you have to introduce a proportionality constant K1. K1 ಅಂದ್ರೇನು? K1 is nothing but proportionality constant. Proportionality constant. Okay, see here. P is inversely proportional to volume at constant temperature and number of moles. When you introduce your proportionality constant, it will become equal. ಈ proportional ತೆಗೆದ್ವಿ ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ಒಂದು ಕಾನ್ಸ್ಟೆಂಟ್ ಅನ್ನ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. So this constant is called as proportionality constant. Here K1 is proportionality constant, 1 upon V. Okay, where K1 is a proportionality constant and the constant of this K1 depends upon amount of gas and temperature. So this depends upon amount of gas N and temperature. This depends upon N and temperature. On rearranging this we get P is equal to K1 upon into this one, 1 upon V. On rearranging this, taking this side, PV is equal to K. PV is equal to K1. So this is the equation of Boyle's law. Right? This says that at constant temperature, the product of a pressure and volume of a fixed amount of gas is a constant. This tells that at constant temperature, temperature constant ittaga product of pressure ಮತ್ತೆ volume product of pressure and volume at fixed amount of gas is always a constant. Is always a constant. It is always a constant. Okay. If you take two gases, ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಎರಡು ಗ್ಯಾಸ್ ತಗೊಂಡ್ವಿ ಅಂತಂದ್ರೆ how to write those comparison between one gas and second gas, first gas and second gas. So like this, PV is equal to K1, P1 V1 is equal to K1, P2 V2 is equal to K2. This is gas 1, gas 1, this is gas 1, this is gas 2. This is first gas, is second gas. So these are constant, both are constant here. K1 constant, K2 constant, ಎರಡು ಸೇಮ್. ಸೊ ಹಂಗಿದ್ದಾಗ ಇವು ಎರಡನ್ನೂ ನಾವು ಈಕ್ವಲ್ ಮಾಡ್ಬೋದು. P1 V1 is equal to P2 V2. P1 V1 is equal to P2 V2, which is both are equal because it is equal to a constant. P1 V1 is equal to P2 V2. On rearranging this, on rearranging, what you get? P1 P2 is equal to V1 P1 P2 is equal to what? V2 V1. Is it right? P1 divided by P2 is equal to V2 divided by V1. V2 divided by V1. So this is the last expression of Boyle's law, which will help you in comparing two gases. When you compare two gases, when you take two gases, you can use this formula. When you are studying only one gas, you can use this formula. ಒಂದೇ ಗ್ಯಾಸಿಗೆ ಇದು ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಬೇಕು, ಎರಡು ಗ್ಯಾಸ್ ಇತ್ತಂತಂದ್ರೆ ಈ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಬೇಕು. ರೈಟ್? P1 V1 is equal to P2 E2, that is equal to P1 upon P2 is equal to V2 upon V1. Okay, next we'll see how it can be represented graphically. On the basis of graph, if you take pressure this side, pressure, volume, x axis volume, y axis pressure. The type of graph what we get is at constant temperature, temperature constant irutte. For example, let us take this temperature, first one as temperature 200 Kelvin. So I'll make different colors for this. So this lines are called as, these lines are called as isotherm. 200 Kelvin, 300 Kelvin. Kelvin is nothing but temperature. 400 Kelvin, different temperature. At different temperature, the curve, whatever curve we get, these curves are called as isotherm. What are isotherm is very important. Iso antandre same, therm antandre temperature. Iso antandre, iso means same, therm temperature, heat. So isotherm means same temperature. That means at constant temperature, whatever we get curve here, these curves are called as isotherm, means which indicate that they are at constant temperature. See, this is pressure and this is volume. Pressure increase ಆದಂಗೆಲ್ಲ volume ಏನಾಗುತ್ತೆ ನೋಡ್ರಿ, pressure ಇಲ್ಲಿ increase ಆಗ್ತಾ ಇದೆ. So for example, let us take this pressure. Pressure is increasing here. Pressure is increasing in this way. ಇಷ್ಟು pressure, ಈ pressure ಅಲ್ಲಿ volume ಎಷ್ಟಿದೆ ನೋಡ್ರಿ, decrease ಆಯಿತು. ಓಕೆ, ಪ್ರೆಷರು ಹೈ ಇದ್ದಾಗ ವಾಲ್ಯೂಮು ಕಡಿಮೆ ಇರುತ್ತೆ, ಪ್ರೆಷರು ಹೈ ಇದ್ದಾಗ ವಾಲ್ಯೂಮ್ ಕಡಿಮೆ ಇರುತ್ತೆ. ಲೋವರ್ ಪ್ರೆಷರ್ ಇದ್ದಾಗ ನೋಡ್ರಿ, ಅಟ್ ದಿಸ್ ಪಾಯಿಂಟ್ ವಾಲ್ಯೂಮ್ ಇಸ್ ಹೈ. At this point, lower pressure, volume is bigger. Higher pressure, volume is small. See, small volume. Small volume. High pressure. High pressure. Higher pressure, smaller volume. Lower pressure, bigger volume. So that means both are inversely proportional. Idu high iddaga idu small agutte. Idu small iddaga this will be high. So means this is low and this is high. See, both are inversely proportional. You can see in this curve that both are inversely proportional. Pressure and volume are inversely proportional at constant temperature. Very temperature. So this is different temperature, this is different, this is different. 200 Kelvin, 300 Kelvin, and this is 400 Kelvin. In different temperature, they give different curve. Okay? And such curves are called as isotherm. The curve correspond to different constant temperature are known as isotherm. Understood first law? There are problems based on this, but we are going to discuss problems and example in the next class. Next class alli examples and problems we are going to discuss. With this, today's class we have completed. Tomorrow again we'll continue with the problems as well as example. Okay, thank you. Any doubt? Okay, thank you.